In this video, we're going to look at collapsing the levels of a factor. And there's probably other ways you could describe that, but what we're really doing is we're taking a factor variable that has many distinct levels, and we are finding some way to reduce that number. So without further ado, here are some package imports, and we are going to bring in a data set that has crime information from state to state. So different states here are in our first column, and then we have these different types of crime, and then that is it. Oh, and also with demographic data about urban population. Okay, so that's what we're dealing with. There is something kind of quirky and weird. The state variable is not named state, and so that fix comes with rename, a very handy pandas function that takes the old name and then we just replace it with the new name, and we just did that as an in-place operation, and so I'll let that stand on its own. So suppose we've got this data and we want to make some kind of state-by-state comparison. There's a lot of things we could do. We could filter certain states to compare them against one another. There's ways we could change the size of a plot, but if we just stick with the defaults, we're going to have this high cardinality problem. And even if we did change the size of the plot, we'd still have a real challenge of separately viewing all 50 states in a meaningful way. So here, this just looks like a big jumble, and we look at that and we might say, hey, is there some way we could still make sense of this data? We think there's more to it. And so what we're going to do is we are going to reduce the number of distinct levels. Right now there are 50. So each state is its own level. And here I did this next line just to see the list of the states. And I hope you'll be very glad that this next code cell is, for this next code cell, I will not type this all here. So I pre-typed it all knowing that this would be a little bit on the painful side. Some of them might be jutting off outside the screen, and I can sort of just bring that in. And I think we've got most of them now here. It doesn't really matter. What really matters is the idea. So the idea is what I want to focus on, and it's all actually right here. So this is probably the most important code cell in the script. For each state, think of that as a key, and then the regions are the values. So we're mapping here, we're creating a data type here called a dictionary, and we're saying that for each state, it's going to belong to something. So the keys are unique. Those are the 50 states. The values are not unique. Many of them overlap. Alaska and Hawaii, I just made them their own category because I didn't know what to do with them, and I didn't want to just lump them together. I think they would hate that just because they're both different. Some states I didn't quite know. Like California, what do you do? I know that's not really Pacific Northwest, but I didn't want to call it Southwest, so I just put it with Pacific Northwest. So don't hate me for that. But I've also got, as you can see, we go through, we've got things like the New England states, Mid-Atlantic, Rockies, Midwest, and so on. So remember, for every state and those are unique, we're mapping them to values which are not unique. So we're going to put them into these groups, and that's going to reduce cardinality. The last couple things, I just was double checking myself. Did I get all 50 or did I miss one? And yes, it is a dictionary. So this is then probably the second most important code cell is the one coming up. So the replace function is going to say, okay, we're going to take the mapping, and where the state was, we are going to basically write over it with region. And I guess I could have renamed that region. In fact, you know what? I will here. That'll let us retain the original, the state values. And so what I will say is crime region. That way we'll still have those. And then what I'll say here is region. So what we'll say now is we'll still retain the states, but we'll have this new variable region. And there we go. And just to see how the whole thing looks right now, let's take a look and say crime.head. And we now have, for each state, we also have its region. And then what we can do is we can pretty easily plot that. So we can compare the regions. Now in terms of In terms of cardinality, we're going to have 1, 2, 3, 4, 5, 6, 7, and then we're going to have 2 that are kind of off on their own, where we're not going to really see much here with a box plot, but let's take a look and just see what we get. So we run that there, and we can now make some meaningful comparisons. So we can see, for instance, that New England tends to be pretty low here for assaults as a group, much lower, say, than the Mid-Atlantic or the Southeast. And we can see that, hey, Hawaii is really low, so they're just hanging out there and doing well. Midwest also pretty low as a group. But what we did here, what we got out of that, was we were able to generate this graph and look at it in a pretty reasonable way, at a pretty reasonable size, because we had so greatly reduced the number of levels of that factor variable. Going from 50 to a much smaller number made it more convenient to display the data and to see those differences. Lots of ways it could be done, lots of different alternatives are possible, but that is a way to collapse the levels of a factor when you are dealing with categorical data in pandas. And thank you very much.